This is lecture 9.2, light gauge steel frame construction based on the fundamentals of construction, 6th edition by Allen and Arnold, published by Wiley. And this is for Architecture 2351, Technology 1. As you can see in this image, which might be kind of familiar, light gauge steel framing is extremely similar to light wood framing. Matter of fact, the only thing a lot of things that we've changed is really has to do with members and that are made out of metal. So if we look here, we'll see that, here's a stud. It just happens to be made out of metal. Here's a rim board. This is a platform here. So this is the second floor platform right here. We can see, rafter, typical rafter here. This is a valley. And then a ridge board, another ridge board right up here. We've got our overhang with our fascia board on it right here. And then these are, of course, outriggers, which are holding up that overhang on that end. So you can see it's very similar. Here's a header, a built-up header there, seal plate, once again, and we'll go kind of over that. But you can see it's just a matter of kind of replacing metal as the primary material with wood, or what we normally refer to as metal studs. The technical name is light gauge steel. You'll see that there's basic two types. One is called a stud or a joist. It is takes the C shape. Okay, we can see here the C shape, and has a lip on it right here that kind of closes that C. And the top piece of this is called the flange. The vertical piece is called the web, and the other bottom piece is called the bottom flange or the flange. So we have very similar to steel construction in the sense that we use the terms flange and web. Its depth, its section, and its width is similar to light wood frame in the sense that it's based on nominal dimensions of 2 inches, just like light wood steel frame, 2 by 4, 2 by 6, 2 by 8, 2 by 10, so forth. The other common component in the light gauge steel is what is called a track section. And you'll notice what I want you to notice is that it has a flange and a web, but it has no lip. It's open. And the reason is because this unit here actually, or component there, slides into this. And you'll see how that works in the next videos. So how are the light gauge steel components created? Well, they are cold rolled. In other words, they're made from a flat. You can see a picture of it right here. This is the original material, which is a coil of flat steel. And that steel is then run through a roll forming machine. We can see a real one right here. This is kind of a image or rendering of one. And you'll notice that, here's the first roller, and then you'll notice that the next roller has some indentions in it. And so it's starting to bend the metal, and this bend is specifically to add some strength to it. You'll also begin to see that this roller is beginning to form the lip to it. And then it just goes through and it slowly, incrementally creates, the shape that it wants through this rolling form. You can see the different stages right here of the rolling that's taking place. And What is the strength of a particular light gauge metal stud? Well, it's based on three things. First of all, the size. Is it a 2x4? Is it a 2x6? Is it a 2x8? So, of course, the bigger the web, the larger the web, the more strong the piece is going to be, the component's going to be. The other is the gauge of the steel. We talked about gauge in the last lecture, and the gauge is, of course, the thickness of the metal. So if we have a thicker metal, of course, it's going to be stronger. So a 2x4 out of a 10 gauge metal is going to be stronger than a 2x4 out of a 24 gauge metal. Okay? And then the other thing that can make a difference is its actual shape. Okay, how we shaped it. So by putting these indentions in it, we're strengthening the metal through geometry, and so that can have an impact on its strength too. When we're doing light gauge steel framing, there's basically three primary components that are used. One's called the wall C-studs, or the wall studs, and the other is, of course, the floor joist, and then the other are rafters, and they're all given the signifier of C because of their shape, of course. And of course, you can see here's the use of studs here in this wall. This is an example of a platform floor, and these are the joists right here, headers and trimmers. And then, of course, here are rafters, ridge joist or ridge beam, and this is a hip roof. This image, I went ahead and included the image of light wood framing so that you can begin to see the connection between the two. And then I'll show you the actual metal later. But a light gauge steel framing, it has the same components, and the components have the same names even that they do in light wood. For instance, on the roof, this is called a rafter. Okay, only it's made out of metal. This is called the ridge beam, only it's made out of metal. And then, of course, the fascia, and then sheathing. Now, that's the one thing that isn't often made out of metal. That's usually is OSB or plywood sheathing, as we'll see in other slides. And then, of course, we've got two double plates here in light wood framing, but this is just going to be a single member here, and it's going to be that U-shaped without the legs, on it, not the legs on it, the lips on it, the track. So this is the top track. This is called the top track rather than the top plate. And then the studs, and then a bottom track. And of course, OSB sheathing on the outside. And then on the floor, we have the same thing. We're going to have a rim joist, a floor joist, and then another rim joist over here, and then sheathing OSB. Of course, it's all cold formed steel. It's uses a 2-inch nominal sizing, and normally it's platform framing, even though you could use balloon framing. And nominal gauge 10 by 24, so the thickest being 10 and the thinnest being a 24 gauge. Remember, gauge in metal, the lower the number, the thicker the metal. And then it's kind of interesting because even though it is out of a non-combustible material such as steel, it's still, the construction type is that same type that is light wood framing. So it's a type 5A or 5B in the UBC code, Uniform Building Code, and it's considered combustible primarily because of the sheathing, and also it's a very light gauge metal, so it can't resist a lot of heat before it fails. Light gauge steel framing of walls. Once again, very similar. Let's take a look here. You'll see that in this wall, here's a stud. Here's the top, what we would refer to in light wood framing. as the top plate. This is called the top track, as it shows right here. As I pointed out, these are the studs, and then there's the bottom track. Of course, when we talk about a bottom track and top track, we're talking about a cross section like this one right here. Okay, there's a track section, and then here's the stud. Okay, and that stud, of course, can slide into the, it's made just small enough, or a little smaller than the track, or the track is made larger, so that they can slide into each other. You'll notice that when you frame a door, you have the same header, you have cripples to make up the distance between the header and the top plate, and then of course a jack stud on one side, and then the stud that runs the whole length is the king stud. In windows, once again, you have a header, cripples that make up the difference in the height of the wall to the header, and then a sill plate or a sill, and then cripples to make that distance up there. So same, a lot of the same, other than top plate and bottom plate. It's called the top track and the bottom track. Here's a typical header right here. Often when they create these headers, okay, they'll do the same thing that you do in wood, and that is you'll take two joist material here, and you'll put them together to a double 2x profile, so that you'll get a 2x4, a nominal 2x4, or you could be 2x6 or whatever it is. And then you can see here they put the cripple right here to the top plate over the door. Why they did that? And then they use, as you can see, steel gusset plates with screws to connect here. Wall, they build it just like they do a light wood frame. They build it on the ground, usually assemble it. You can see here a wall, and this is a window, right, that he's framing in. He's using the members as in diagonal to do the cripples instead of vertical. That gives it a little bit more strength. But you can see, here's a stud, here's an internal brace, and the stud. But they'll build this on the ground using a screw similar to this one right here, from 1/2 inch to 1 inch in depth. You'll notice it's very pointy at the end, and that's the reason is this metal is thin enough that they can just push it into the metal with a drill, and the point will start it, and once it hits the threads will pull the screw through, and so you don't have to pre-drill any holes. And here you can see a stud is right here, and this is a top track, and the stud slid up into the top track, and they're screwing it and holding it together, so it's easier to screw with some vice grips right there. Once again, here's a typical truss. Notice there's a hole that's been pre-punched through that stud. That allows us to run electricity, also plumbing if need be. And then here's a bottom track. This is a top track there up above, but this is the bottom track here. And you can see where that wall has been probably hilti gunned or to the concrete, or maybe screwed, but I doubt it's screwed. It's probably been shot. We'll talk about that kind of stuff later. And so they raise it up. Once they make it on the ground, they raise it up and seal it to the concrete slab usually, or they'll screw it in if it's a platform floor. And then of course they come back and then sheet it, okay, just like they did here with OSB. They screw OSB onto the top of it. This may look very familiar. If we would just change the material out to wood, it would look probably really familiar, but let's go through some kind of the basics. The basic unit to a floor is a floor joist. Then you have rim joist. These rim joists here, these are C-shaped. In other words, they're you know, got that lip on them. The rim joists are just a track. In other words, there's no lip because the joists have to slide into the rim joist, and then, of course, it's screwed together at the ends. Openings are dealt with in the same way that they're dealt with in lightwood framing. You have a joist, the direction of the joist. One side of that is the opening is called the header, which we can see closer up here. Notice that they've doubled the joist here in order to make that stronger for that opening. And so this is the header, and this is the header here. And then, of course, the trimmer, this would be a track that would close off the joist that have been cut to create the opening. So these joists have been cut, of course, to create the opening, and we use headers and trimmers to close that off. You'll notice also there's bracing right here. There's metal strapping that's being used as bracing. That's similar to the cross bracing that made out of wood, or blocking. You know, you put in a block in here, or the blocking that you see in lightwood framing to create some lateral stability to that joist. To create a floor platform, once again, to kind of go over the different elements, you'll notice here, this is, for instance, this could be a stem wall or a foundation wall of some type, and you'll notice the directions of the joist are running perpendicular to that, and of course they sit on the top of that wall, and there are brackets that are used and bolts, once again, that bolt that down to keep it from sliding on top of that foundation wall. And then, of course, here's the rim joist. And they normally use a glue, some kind of flooring glue to adhere more effectively. That's basically not for strength of adhering, even though you get some of that, but it's a lot to keep the floor from squeaking. In other words, if you just rely on the screws, that OSB may start to squeak on you, so you might get a squeaky floor. So gluing it down helps that a lot. And you'll see the OSB here, which is screwed then to the joist right here and here. Now, if we look at 90 degrees, you know, another foundation wall that's running 90 degrees to this foundation wall, that would be this one over here. And you can see now the joists are running parallel to the foundation wall. And then they just use cripples in here, or they call them closer channels, to close off and strengthen that connection to the rest of the floor. And then they use the same kind of brackets and bolts into the foundation. And then OSB screwed right to the joist. And then you'll notice that they come back after they finish the platform, and they set up the walls with a joist there, and then they will screw the bottom track to the top of the floor there. Of course, the second floor is very similar platform that the bottom floor is, or if you're using a framed floor for your bottom floor rather than a slab on grade. But you can see here's the track for the top track for the wall. Here's the stud for the wall. Same thing over here, right? Here's the stud, and here's the top track right here. And then all they do is, depending on which directions the joists are running, if they're running parallel to the wall, then this condition is used, and they screw. There should be some brackets in here that actually connect that, right? So they'll bracket that down, and then once again use closure channel right here to close that off. Same thing here. If the joist is running perpendicular to the wall at 90 degrees to the wall, then of course what you're going to have is a rim joist right here, and they're going to glue the subfloor down and screw it, and then set the next floor up on top of it. Of course, this slide shows you how the roof is framed. This is a good example right up here of, and here you've got your rafters, right? You have your ridge board or your ridge rafter. Sometimes in steel framing, they'll call these joist, but they'll also know if you're calling them rafters, they'll know that they're not roof, that they are roof joist. And so you have, once again, all the typical characters. When these rafters come down and sit on top of the wall, in this case, I'll just talk about the framing of this particular building because it's kind of unique. You can see that the first floor is sitting on a slab on grade, and then here's the platform for the second floor. And then they've built a little short wall right here all the way around to increase the height of the roof so that they have more volume in the second floor. Evidently, they're planning on making that second floor a major part of not just an attic space, but actually a second floor. And so they've added some height here. Looks like about 3 feet or so, 3 or 4 feet, to get some height, more height and more volume into that second floor. So they've created a second little, often referred to as a pony wall. And anyway, that's their second floor. And then their rafters are sitting on top of that. So we have right over here on this drawing, we have a rafter that's sitting down on top of the top track of a wall. So this is the wall top track. And then they use a bracket because, of course, they can't cut effectively. They hurt the integrity and strength of the rafter if they cut into it to create a bird's mouth. So they're just bringing it down so that it's sitting on this edge, and then they use a bracket, as you see right here, and they'll screw into the rafter, they'll screw into the top of the plate or the top track, and then they'll screw it here too. So you can see it's all secured together. And then you'll see the ceiling joist right here. There's a ceiling joist that's been clipped in there, and of course that is screwed to the rafter itself too. Here's an example of a hip roof, and we have a ridge coming here, and then here's your valley rafters, and then right here. And then instead of bringing this rafter all the way to the ridge board, as you would do in wood, it's simpler to make that connection if you put a closure in there. I think it's called a 90-degree hip connector, okay, at the roof ridge, and then that gives that board, or that, not board, that metal stud, that metal rafter opportunity to have something to hit into, and then you can more easily put on a clip. This is a flat roof here. You'll see how trusses, actually this is a buildup of trusses using ceiling joist or joist, and then studs as webbing. So you can see here, these are stud pieces, right here, here, and here. And then this is the bottom cord, which is just a rafter. And then you'll see the top cord is a rafter. And so what they've done is they've actually just built a joist, a steel joist out of these different members. A steel truss out of these different members, a truss joist. So that's one way to do it. The other is you could buy pre-manufactured joist, steel webbing with possibly wood flanges, and use those instead. Once again, a couple more images of the roofing condition. Closer view of the ridge. Here's the ridge. Notice to create that ridge beam, they nested two steel joists together, as it says right here. So they turned around so the C's match up with each other and overlap, and then they'll screw them together up here at the top, so they work as one unit. And then the rafters as they come, the rafter here as it comes up and is cut, plumb cut there and connected, they use a bracket instead of toe nailing it in like you would with a light wood framing. They'll just screw it together with a bracket. And then this rafter here, of course, as it continues down and hits on top of this wall, you'll see a bracket. It's better over here. You'll see that they have a bracket right here that's between the ceiling joist. There's a ceiling joist right there, and the rafter right there, and then in between them, kind of hidden from our view, is a bracket. And of course, that bracket is then screwed down to the top of this wall track, and then screws are pushed through, connecting the ceiling joist, the rafter, and that bracket to tie it all together. And then you'll see right down here to create this closure for the soffit, because they're going to add some kind of sheathing onto the bottom of this, and then later come back and add a fascia plate right here. Could be metal, most likely it will be, but it also could be wood. Most likely they'll use a metal fascia plate right there. But here you'll notice that there's this piece of stud, okay, that's been used to frame that out, and then there's a track right here, okay, that this slides into, and that track then is how it's kept in place. And then of course it's just screwed to the rafter over here, and then screwed at the top here and at the bottom there into that track being used as a soffit joist.